Hey, how's it going? So I've been getting a lot of requests for creating the Planet tutorial series based on the third-person blueprint. Um, it doesn't really work that way without doing C++ and getting the engine source code to change how gravity is calculated. Um, or just C++ in general. I've seen it done in C++, but I don't really want to get into that much right now. But I will show how to kind of fake the third person. Basically, what I want to do is kind of start over with the Planet series, make things a little bit more clear. I feel like that was kind of confusing, I guess you could say. So I'll go ahead and start off. We'll start off with a third person blueprint. Um, and then we'll implement all of the stuff we need working afterwards. So I'm gonna name this Planet Series New. Go ahead and create the project. I started this in this is in 4.14.3. The original version um, was in 4.10, I do believe. And original here, it seems. Just bear with me one moment. Sorry. Okay, I want to open up my original one so I could use it to take notes. Yeah, it was the original was in 4.13. Okay, so the basically we need it, and we need the character to be a pawn. Um, the third person character is based on the my character blueprint. So right here, and basically all of the movement is built into this character. Um, and that really won't work um, because this movement that's automatically implemented has its own physics kind of scripted into it. And we can't be using those physics because we're kind of walking around a sphere, so to speak. So we do want a pawn. Um, that over there. So in order to really get this to work, um, we need to first create our planet. Um, get that functioning. That's going to be a very similar system to what we had before, and then we'll work on the getting the character situated and get the movement functioning. So, all right, so we'll go ahead and create our planet. Um, and this will be basically getting the surface location working and stuff. So on content, we'll go here and we'll go. I'll just put kind of all of the files we want to keep in here. Um, planet series. Open that up, and this will be planet underscore BP, and we'll start here. All right. So basically, we just want to create a blueprint class and an actor, and this will be our planet underscore main. Open this guy up. All right, and basically, all we really want in here is a static mesh for now. And then this will be our planet. And we want to implement shape sphere. No, we don't want to. Well, for now we'll use the material sphere. That way the origin is in the center. There's ways of messing with it, but for now we'll just kind of work with this. So compile, save, and now we'll go ahead over to the construction script. And then we'll need to create some variables. So this will be radius in meters. This will be our float. Excuse me. We want radius in units, not unities, units. There we go. Compile, save. We want to get our units in meters. We want to set our radius in units. So we'll multiply our meters by 100, essentially converting them to the Unreal units. And then we want to basically get the bounds of this. So we gotta get component bounds. But we only want to get the sphere's radius, because we are in fact working with a sphere. So we'll grab the sphere radius, and we want to divide the sphere radius by the radius in units. Go ahead and divide here and here. And then we want to basically just set the world scale. And basically what this is doing is setting the overall scale of the planet based on what we set the radius in meters to. So radius in meters, if we go like 5 just for starters. Go out and you see it gets bigger. The material sphere is not ideal because we're going to get these flat edges when we put a material on it. Somebody shared a image of their sphere doing that in the comments, and I wholly intended on responding. I completely forgot, and I do apologize to the individual that was. I can't remember your name right now, but I do apologize, and that's actually part of the reason why I'm making this tutorial, because I know you guys have been waiting for it, and I haven't really had the time to dive into it. And I saw the comments, and I wanted to start over and make it cleaner for you guys. But we'll keep moving on. So now we want to create a function. And this function is basically going to get the surface location. And again, I'm pretty sure I mentioned this before, but this function I actually got from another video, which I linked in the previous video. I talk about this at, but I'll link it again just to make sure that they get the credit that they deserve, because they're actually the ones that came up with this. So I created a function, get surface location and normal at, and you select this and you do an input, and we're going to do a vector. And this vector is going to be location. File save. And now we want to get this actor's location. And we want to subtract the location we input here with the current actor's location. And then we want to normalize that. And normalizing basically, oh, whoops, I don't want to do that. If I returns a unit normal version of the vector. So basically, I can't think of a proper way of explaining it, so I'm just going to grab the Unreal documentation so I can get a better... I can't think of the words right now. And I definitely recommend checking out the Unreal documentation or the UE4 answer hub. Okay, so, this guy explains it perfectly. Right here in the answer hub. I cannot pronounce your name, but that person right there. says normalize in vectors means to change the vector so that it points in the same direction. So kind of like um, a forward vector, sort of. If that's my understanding of it. So yeah, if that kind of puts it clearer here. So, and basically what we want to do is multiply that location by the units. And remember, we're actually setting the units in our construction script. We're multiplying it in meters, the meters by 100, and setting the units. And that should get our extended location. And then we want to get the actor's location again. Add these two together. Vector and vector. And now we have our return node. So we want to select this guy, and we want to, on the outputs, create two variables. The top one will be surface location, and the bottom one will be surface normal. Now, guy over here. And now, right after we normalize, this will be our surface normal. And then the surface location will be right there. Compile, save. And now we have our little function here. Now we can go ahead and move on to our event graph. Oh, we actually don't need our event graph yet, because that will be for spawning in the items that we need. Okay. So we'll close this guy out. We don't really need him anymore. And now we want to create our character. And I wonder if we can do this. Let's try this. Let me duplicate him. Then edit. Parent blueprint. Can I make you a pawn? Let's see here. I think I can make you a pawn. Let's try this. Parent blueprint. Pawn. Okay. Parent. Alright, so let's actually let's undo that. Excuse me, I'm sorry about that. Okay, well we don't need you. We don't need jumping just yet, because jumping isn't an option here. Okay, and let's see if just doing this will work. What I want to do, I just want to see if this character will move. So we'll go to parent, or blueprints, I'm sorry. Person character, select pawn class, and we'll do third person character 2. Let's delete him, bring the guy out, up, and play. Oh, wait, what's going on here? Hold on. Did I lose all of my information? Ah, yes, okay, it did delete everything. Alright, that's no big deal. Basically, I want to set this up just like the regular third person character and see how this goes. I haven't tested this yet, but we'll work it out here. I'm gonna drag this over here. Maybe I won't. Let's see. There we go. And there we go. Okay, so I'm going to close out, or no, I'll keep the details panel open. So we have our capsule component at the top, so we want that first. We'll keep it there. Make that the parent. And we want this to be 96, 42. No, not by 12, by 42. Thank you. Dynamic. And again, I'm just kind of going down the list and copying. Guy here. We'll keep the collision preset at default first. And let's see. Can character step on? No. Okay. So now we don't need the air component, but we do need a skeletal mesh. Skeletal mesh go. Oh, no. Okay, that's fine. And then we don't want material. This right here, SK mannequin. Negative 97. Negative 90. And now we should be facing forward, which he is. Okay, that's good. Now the camera boom I want to just set up here. It looks like everything is fine. Should be fine. So I'll just this guy in here again. Open a new window. Okay, so now I can look around him, and that's fine. Right. Now, just want to delete. Okay, so now that we have that going, this is our main character, so let's toss him into our character BP, our folder here. That way he's in there. Make sure everything is good. Yes, for now. For now, everything is fine. Okay, so here is where we want to focus on the code from the twin stick blueprint that we created before to kind of get this functioning the way we want it to. Now we'll open him up. Event graph. Let's leave this with everything with that. And yeah, let's leave all these for now. We'll come back to these after. Okay, so first off, we want to be able to set our planet variable. So we want event begin play, get all actors of class. Planet main. And then we want to get the first element of the array. So basically this is essentially kind of putting all of the actors that share this parent into an array, getting that array, and then we can select the index from it. Kind of like a box, and we select the very first one that comes in, which is, in this case, 0. So we'll promote that to variable, and that'll be our planet BP bar, and we'll set that. That's all she wrote for that. I'm just gonna move him over right there in case we need event begin play for something. And now want an event tick. You know what? No, we don't. I don't want to do event tick. I want to do custom event, movement, and we can set timer by function name. Call this movement. Looping. We'll set this to 0.01. That way, every 0.01 seconds, it checks this again. That way the movement is smooth. I mean, you can do event tick if you want to, but it's not ideal, I guess you could say. Oh, but we need delta seconds, don't we? You know what? I'll do event tick, and then once I figure out, we'll just leave these, but I'll disconnect them. Actually, can I get delta seconds? Get world. Okay, I can. Sweet. So I don't need this. So yeah, just keep that set up there. Alright, so basically what I want to do, I want to get move forward, get move right. And I mean, if you want to copy what we did before, that's totally cool. Because this is pretty much going to be the same thing. And then I'm just going to kind of build off of it, I guess you could say. We want to clamp the vector size between 0 and 1. And the reasoning for this, if you look, let's go to the project settings real quick. This is just to show you not to copy anything. If you go into axis mappings, you'll see when we have move forward, it's between a value of 1, or if you want to move backwards, it's -1. So the reason we're clamping it is so the move forward and move right are clamped between 0 and 1. So it only moves between those two things. Okay. Alright, so now we want a vector variable called movement speed, and that'll be our float. And we want to get that, and we'll set that guy to like 1,000 for now. Probably way too high, but we'll see. Excuse me. And then you want to multiply the delta seconds with the move speed. And then we want to add actor local offset. Guy goes in. Nope. Not there yet. We want to multiply by a float our movement speed. And then go. That way, when we're going along, it will change the speed of our character. So it won't always be like 1, 0, 1, 0. It actually gives a value to the speed so it can move across. Alright, now we need our surface location. So we'll get surface location normal at get actor location. Okay. And we want to set actor location and rotation. Set the actor location to the new location. And then we want to make a rotator by Z and X. You sure? And then we want to get actor forward vector. That way the character is always kind of looking forward, and not just kind of moving around and stuff like that. Okay, so we got our mouse, but I believe I'm gonna need to compensate for the actual rotation. So the camera rotates with the character. But let's try this out and see what it does. Of course, our character is not going to be um, walking or anything yet. But we'll see. So let's bring our planet out. And let's put player start top of that bad boy. And let's see if this works. Okay, so we're walking around it. But camera, the camera boom needs to be attached to the mesh, does it not? Pretty sure it does. Okay, let me finish up the code real quick, and then we'll take a look at that. Um, Alright, so just as I thought, I want to just straight up delete these. We want to keep turn and look up. Okay, and on turn, we want to grab our capsule, add local rotation, and this rotation we only want on the Z axis. So make rotator, put it on the Z. Bam. And then the next one, copy that. And we want to multiply by a float, by -1. That will be on the Y. But this will be actually on the mesh, I think. Yeah. Well, we'll try it and see how it works out. See what happens here. Okay. Maybe it's because the camera boom. Try deleting the camera boom and see. See what that does. Okay, so this needs to be up, not on pitch, on roll. Or is that on C also? Okay, so that's looking up and down. Okay, so let's go ahead and move this upward. See what that does. Okay, so it's doing 0. So what I'm gonna do that -97. Yeah. Just so everything's even, I don't have to mess. No, actually, I'd be plussing it because I want to move it up, right? So yeah, so it'll be +7. And let's see how that does. Okay, nope, that was the wrong place. Wrong place. Where do it? Must be. Here. I think I was totally mistaken. +7. Alright, well. Not sure why that's occurring. That's kind of weird. At the location, I'm setting it at the surface location. It should be right here, but it's not. So, I'll just I keep doing that. Okay. And let's see if I can add that camera from again. The spring arm, I mean. Okay, so now we got our character kind of moving around here. A little buggy, but we can also class defaults. I don't want to do that. We just want to. Okay. And can actually do here. Alright, so now it kind of. Do a clamp on that too. And then what I want to do. Actually, no. This at the end. And oh yeah, and we want to. Oh, okay. That won't work. Oh, I don't want that. What? Oh, what am I doing? It'd be the wouldn't it? Okay. Okay. What we can do is branch, and if but that won't work because. Okay, that will work. Alright, so now it's not attached to the skeletal mesh, so I can rotate it. So basically what I want to do is when y is greater than 0.1, we'll do 0.1. Greater than 0.1. But okay, we'll sequence this because it needs to be the second. First, bring these guys there for now, bring you down. Okay. So when y, which is our move right, is greater than 0.1, I want him to turn right. So if we look in our viewport, right would be a positive. Yep, positive 90. We want this to happen do once. And only reset on false. This will be 90. So let's see if that works first. Alright, and basically we'll do pretty much the same exact thing again. We want less than 0.1. No, we want negative 0.1. And can I do that? No, I can't do that. Bad to sequence this? I don't know if this is bad practice or not, so. I'm gonna have to look that up as soon as I'm done. I just want to see if this works real quick, and then check it. Because basically what I want is okay. No, this isn't gonna work, I can tell you that right now. And the reason, we're gonna have to do more code in order to bring it back when the button's released. Show you. I see, so it's not gonna let me. Okay, so I need to treat this like, I don't want to add local rotation. I want to set. Set. Is that relative rotation? Maybe? Okay, and then what's this? So the rotation is at -90 forward. Look at this. 0 puts it there. -180 puts it there. Okay. So 0 to go right. Fine. And -180 to go left. Okay, now we just want to do forward and back. To view. There. Copy that. But this time we want X. And if you double click on the line, that's what creates these the reroute nodes, so you can connect them up. Okay, so we want forward to be -90. I think it's going to be like 90. Okay, and now we got to do a blend between the two. I wonder if I need that anymore. I don't. Okay. Because I'm not adding constantly, so I don't need those anymore. should work a little better. But it still doesn't blend them. Do 1/2. I mean, we can add that pretty easily. Oh, we'll wait on that. We'll just do this for now. So yeah, so we got this implementation going where we can kind of look around. But we want to always keep the camera rotated with it, which means the red axis, the x-axis. So I know it creates a lot less pins if you don't do it like this and you just do a make rot, but I like doing it like this. And I can get actor. Oh. Just so it doesn't like reset it or anything. Ooh, yikes. Okay. Let's try just like this then. Okay. Oh, you know what? I wonder if it would just work if I get world rotation split, and I wonder if I just set the X to the X. If this will work, but okay, I don't like that. Alright, I'm gonna have to follow up with a camera smoothing tutorial. Kind of smooth out that. But yeah, let's try this just for the heck of it. I mean, This wasn't too bad when I did. I spin it. When I did the, I think it was a pitch with the X. Alright. So I'm going to look up a tutorial on that, but for now, this works. Okay. So now, probably want some animations. So we'll go into the content browser. Asset actions. New. I wonder. Open this back up. Our mesh. See if we could use. Okay, so now we have to link. Okay, so this is getting velocity. So it should be. Is velocity character movement thing? Alright, and this is where documentation comes in. We do Google yeah. And we don't want to use C++, so we'll back out of here. And UE4. Let's try idle walk cycles. Could try dealing with our movement speed too. I just find it interesting because we're getting the velocity. Returns velocity in centimeters per units. Using physics or has an associated movement component. Gotcha. It's not using either. I'm literally like setting the location of the character over and over again. So that said, I can cast to the third person MVP. I don't want to do that right there. Here, check speed. And what do we want to set it to, you ask? Well, we can set a vector with these values. Maybe. Name of velocity. We'll do vector. This. I guess we only need and we'll get our velocity. That won't work either, will it? Let's try this. Together. We'll see how this works. I'm not guaranteeing anything, but it's worth a shot. Oh, I gotta call this now. That. Speed. Just disconnect this. Axis. Multiply by 100. Normalizing might just work, do the trick. Okay, so doing both positive values. Both positive values give us that. But of course, negatives stops moving. Because left and down are both negative values. So of course it's going to be doing this. So how do we stop that? Well, do branch want to know is this positive? So we'll do greater than greater than 0. Do like normal. But false to take all this and but yeah, if it is less than 0, and there we go. Got our character running. We don't have the angle set up yet. He's not facing those angles, but we could do that later on. So we've got our third person character working in here. Oh, you know what we gotta do? Less than negative 0.1, greater than 0.1. Okay, oh, and we want to set speed to 0. Those are false, right? Okay, so now I'll save all. Let's make our planet bigger. Go ahead and delete that. Did I not make that public? Radiation meters. Public so we can adjust it. Damn. And no, it's not perfect. But it works. Just gotta fix running at those angles. That functions. Alright, well I'm gonna stop this here. Go take a break for a little bit. I'll probably be back. Wow, I've already been going for an hour. Alright guys, well take it easy and I hope this is helpful. Thanks for watching.